Hi, I'm Ms. Roger, and welcome back to Core Concepts in Algebra 2. Today's lesson is on solving systems of linear equations algebraically. The Massachusetts curriculum frameworks for mathematics are specifically tied to this lesson. A-CED, creating equations, number 2 and number 3, and F-IF, functions interpreting functions, number 9. Let's take a look at our first problem. Y equals 4x minus 21 and y equals negative 4x plus 11. So we're going to solve this system by substitution. We want to take a look at what we notice in both equations. Both of these are set equal to y, the variable y. So in this case, what we want to do is we want to substitute the expression 4x minus 21 into the second equation. This is going to allow us to solve by substitution. Now our goal is to solve for x. Solving by substitution allows us to break these two equations down into one equation with one variable. So we have a multi-step problem. We have a couple choices. We can add 21 to this side of the equation, we can subtract 4x to this side equation, we can add 4x to this side equation, or we can subtract 11 to this side. We have a number of options, and this is just personal preference what you choose to do. So I'm going to start by subtracting 4x to this side. No reason, just 'cause. And now I only have one choice. I need to bring 11 to the other side of the equation. To do that, I'm going to subtract 11 from both sides. Negative 21 minus 11 is going to give me negative 32. And now I have a one-step problem. So I'm going to divide by negative 8 on both sides. This is going to give me 4 equals x, or the way that we typically like to see it is x equals 4. We're not done. We've only solved for x. If we take a look at both of our equations, we need to solve for both x and y. The process now is going to be to substitute x equals 4 into one of our two original equations. It's your choice which equation you choose to substitute it into. So I'm going to substitute it into this equation. Notice when I substituted 4 in, I inserted it in with parentheses. So here we have y equals negative 5. With x being 4 and y being negative 5, we now have a solution to our system. This solution will be true for both this equation and this equation. That's solving by substitution. Let's take a look at problem number 2. This problem is a little bit different. If you notice, the last equation is solved for y, but the first equation is not. This is a little bit different from our first problem. So again, we want to use the substitution method, and we're going to substitute negative 4x minus 14 every single time we see a y in the first equation. So we're going to insert it in here, and then we're going to substitute. Notice how we inserted it in with parentheses, and we're going to see the distributive property in action. So negative 7x plus 8x plus 28 equals 24. I have some like terms. Negative 7x and 8x are my like terms, so I'm going to combine those together and get a 1x. I have a two-step problem. I'm going to subtract 28 from both sides. And x equals negative 4. So again, the whole point of this is to go from two equations with two variables down to one larger equation with just one variable, specifically in this case x. And we end up solving for x, and now we're able to go back into one of the two original equations and solve for our missing y. That's going to give us an ordered pair, which is the solution to this system. So I can choose whichever equation I'd like to substitute this in for. I'm going to pick the second equation. It doesn't matter which you pick, it should work for both. In this problem, y equals 2. Negative 4, 2 is our solution to this problem. Let's take a look at an elimination problem. Elimination problems are going to be broken down into 4 different types, so we can think about them when we get a problem that we're not sure how to solve. This problem, what we're going to do is we're going to try and add the two equations and see if we can eliminate one of the variables. So if I'm looking at this equation and I'm trying to figure out if anything eliminates when we add down, our negative 3x and our 3x, when added together, will eliminate. If I add 7y and negative 5y, I'm going to get a 2y. And negative 13 plus 11 is going to give me negative 2. Now I can solve for y. Y equals negative 1. Similar to in the substitution problems, we're going to take y equals negative 1 and substitute it into either the original equation, the first one, or the second one to solve for x. I'm going to substitute it into the second equation. For this problem, x equals 2. Our solution is going to be the ordered pair 2, negative 1. Make sure your x comes first and then your y. If I were to check this, I could substitute this into the first equation to check. Let's do that. Negative 3 times 2 is negative 6. 7 times negative 1 is negative 7. So negative 6 plus negative 7 is negative 13. So that verifies that the solution 2, negative 1 will satisfy both of these inequalities. Let's take a second and verify that our solution 2, negative 1 satisfies the second equation. 3 times 2 is 6. 5 times negative 1 is negative 5. 6 minus negative 5 is 11. So this does verify that 2, negative 1 is the solution to this system. And we solved it by elimination. This is our next type of elimination problem. The first type, we were able to add the two equations down and one of the variables eliminated. This type of problem, something similar happens, but we do have to manipulate one of the equations. So if we take a look, if we were to add down, nothing necessarily would cancel out. So what can we do? Well, we could eliminate 7y and 7y if we were to multiply one of these by negative 1. Let's do that. to keep the first equation how it is. However, I'm going to multiply the second equation, the whole equation, by -1. This is going to allow me to transform this problem into a type 1 problem, which is the previous problem we just worked on. So if I multiply -1 times each of these coefficients, I'm going to get this equation. Now, if we add down, notice the 7y and the -7y cancel out. So 3x plus 1x is going to give me my 4x. And we get x equals 5. Now, let's solve for y. Let's go into one of the two original equations and substitute x equals 5 in to solve for y. Let's go into the original. For this problem, y equals -3. We have a solution that's an ordered pair. (5, -3). Let's take a look at our third type of elimination problem. Our first problem, we were able to add down and one of the variables eliminated. The second type of problem, we were able to multiply one equation by -1 and one of the variables eliminated by adding down. This is our third type of problem. How can we make it look like the first type of problem where we were able to add down and eliminate a variable? If I take a look at both equations, I can take the second equation and multiply it by -2, and then I'll get a 14x and a -14x, and that will cancel out. So let's do that. Our first equation is going to stay the same, and our second equation, we're going to multiply the whole thing by -2. So -2 times 7x is going to give us -14x. -2 times -4y is going to give us an 8y. And -2 times 5 is going to give us a -10. Now you can see clearly that this is the first type of problem we worked with different numbers. The 14x and the -14x are going to cancel out when we add down. -6 plus 8y is going to give us a 2y. And 18 plus -10 is going to give us an 8. For this problem, y equals 4. Just like in all the other problems, we can take our value of 4 and substitute it into one of the original equations for y in order to solve for x. I'm going to work with the second equation to do this. Notice how I substituted 4 in using parentheses. For this problem, x equals 3. We have a solution. Our solution is the ordered pair 3, 4. Let's take a look at our last type of elimination problem. This problem is not like the first type, the second type, or the third type. However, there are similarities. We want to break it down to be the first type of problem where we add down and can eliminate one of the variables. So using what we did last time, we might have to multiply both equations by some number. I have a few choices. I'm going to multiply the second equation by 5 and the first equation by 2. What I foresee happening is getting a negative 10x and a positive 10x, which will eliminate and break us down to the first type of problem. I need to multiply 2 by every number here and 5 by every number here. I'm now ready to add down and get my x to eliminate. For this problem, y equals negative 3. Now I can go back into one of the original equations and solve for x. For this problem, x equals 9. We have a solution. Our solution is going to be 9, negative 3. This solution satisfies both equations. We will be talking about checking problems tomorrow during class. What is the benefit of solving a system of linear equations algebraically? When does the substitution method work best? When does the elimination method work best? And what type of solutions are possible? Think about these questions tonight, and we will discuss them tomorrow during class. After watching today's videos, try these. The first problem is solved by substitution. Notice that we have an x and an x. It doesn't matter what type of variable we have, x, y, we can still solve this using substitution. The next problem is an elimination problem. Determine which type of problem it is and solve it for tomorrow. Thanks for joining me in Core Concepts in Algebra 2, and I'll see you next time.